Welcome to physics class. In today, I want us to play with this instrument to be able to understand what Hooke's law meant. First of all, I would like us to know that for us to be able to understand this topic, we need few apparatus like this one now. This one, spring, and this spring has a constant called stiffness of the material or elastic constant or force constant or spring constant. Any of these words can help explain what the nature of the material is, and any of them can go, and they all mean the same thing. Now, I want you to look at what happens to this spring when I start to be increasing this spring constant. It's becoming thicker as you're seeing it. And this spring constant is measured in Newton per meter. Newton per meter. So as I'm reducing it, you see what happens. When we are going to be loading forces, you will know. We are still explaining what we have. The next thing is called the applied force. This applied force is just pulling and pushing. But we are going to be using this icon, this place, to be increasing the force. Okay. Now I also want you to notice that there is something we call equilibrium position. And this equilibrium position talks about the length of the spring before the force is added. And also, we must talk about displacement, or should I say, the length the spring has expanded to when the force was applied. Now, let's get over it. One more thing I want you to know is this. We will not be able to talk about Hooke's law without first understanding what is elasticity. And I'm sure you've heard that word, elasticity, like the rubber band or some other materials like a spring, such that when you pull it, it expands. When you release it, it goes back to the original shape. That is called elastic material. Now, according to physics, and I'm going to be using this spring to explain what I mean. Let me put value so that it will be easier for us to know what is going on. Okay, and let me reduce the spring constant. Okay, I reduce it. Let me put it at 230. Now, see, let me go back to zero force. Okay, now at this point, elasticity is defined as the ability of a substance to regain its original shape and size after being distorted by an external force. This external force is here. See, as I'm pulling it, you see 63 78, and then 100. So I have applied a pull of 100 Newton to this spring. When I release this force, the spring, now, okay, when the 100 Newton was applied, the spring has increased by 0.435 meters. Now, this guy is saying that elasticity is saying the ability of this to regain its size and shape. Now, you see, once I left the 100 Newton, the spring will go back to its original shape. So this is 100 again. When I release it, it will go back to its original shape. So once I pull it apart and release, it will come back to the way it used to be. And that is what elasticity is talking about. The material that can carry 1000 Newton is not the same thing as the material that can carry 100 Newton. So the bigger the force you want to use the spring to carry, the more the stiffness of the material. Now, if I put it at 100, if the stiffness of the material is 100, as you are seeing it now, if I apply a force of 49 Newton, you see the spring has increased to 0.49 meters because the stiffness of the material is 100 Newton per meter. Now let me increase the stiffness of the material and you look at what is happening to this extension or displacement. You see, as I've increased the stiffness of the material to 370 Newton per meter, the extension has reduced. So the stiffness of the material varies from spring to spring.